Hey guys, welcome back. Now that you're here, we may as well continue our talk on particle theory and heat transfer. Today we're talking about thermal radiation. Let's get to it.
Yes, I love science!
In our previous lessons, we talked about conduction, where the particles need to bump into each other physically in order to share their heat. And we also talked about convection, where particles move around in a current in order to move heat around. But our source of heat is the sun. So how does heat from the sun get to the Earth? Unlike Earth, space is a vacuum. No, not that kind. The vacuum of space is nothing. There's no particles to share heat that's needed in conduction or in convection. Heat from the sun travels by electromagnetic waves. This may be a new term, but you have heard the different kind of waves before. The electromagnetic waves are radio waves, microwaves, infrared radiation, you may have seen this with heat vision goggles or thermal lenses in video games, visible light, so everything that we could see, ultraviolet light, X-rays, and gamma rays. The sun emits infrared light, visible light, and ultraviolet light. We may not be able to see them, but they are all sources of light, which is a form of energy. More importantly, they're a form of energy that can travel through a vacuum. When this light hits an object, it's absorbed, and the energy from the light causes the particles to heat up and move, creating heat.
We know from experience that the light from the sun produces heat. On a hot sunny day, when you stand in the sun, it feels extremely warm. However, when you stand in the shade, it feels much cooler just because you're out of the light. It's being blocked by the tree. So what that means is the light, or the thermal radiation coming from the sun, is producing heat. Now, the sun isn't the only thing that actually produces thermal radiation. Anything above absolute zero, which is everything, produces thermal radiation. But the warmer it is, the more thermal radiation it'll produce. So you end up getting a hot cup of coffee, you end up putting your hand near it, you will actually be able to feel the heat coming off of the mug. Same thing with your oven. You can actually put your hand close to the stove or the oven and you'll actually be able to feel the heat coming off of it. Now we actually use thermal radiation to cook fairly often. So when you make toast in the morning, those elements on the side are actually producing radiation. Your toast isn't touching it and it's not by convection, it's from the radiation. Same thing with the broil element inside your stove. If you want to cook the top really quickly, you end up turning on the top element and it actually cooks by radiation. And everyone's favorite in summertime, you go out and you roast marshmallows, hot dogs, etc. over top of the, or by the fire. You're not touching it, you can actually hold it off to the side and it will cook extremely fast. Why? Because the coals are extremely hot and they're producing a lot of radiation.
We remember from previous years in science that we see colors because light is reflected off of them. Dark colors absorb lots of light, so they look dark. Brighter colors reflect light, so they seem bright. Darker colors absorb more light, which is converted into heat energy, meaning that lighter objects absorb less light, meaning they are not going to get as hot. Now we know this from experience. During the summer, on really hot sunny days, what happens if you wear a black shirt? It gets really hot. The reason for this is when the light from the sun hits your shirt, the black absorbs all the light energy. This causes the particles to move faster, heating them up. However, if you wear white or a brightly colored shirt, the light is reflected and you stay cool. This is one of the reasons why in really warm climates, people are seen wearing bright clothing that covers a lot of skin. It keeps them cool, even more than if they wore a short-sleeve shirt.
One more important thing to note about radiation is that it goes through clear or transparent objects. So a window would allow sunlight to come through and warm up a room. Another place that this is extremely important is for those of you that enjoy baking. If you have a metal pan, what ends up happening is the baking element, heat comes from the bottom, and the radiation hits the bottom of the metal pan and reflects away. And so the bottom of whatever you're baking will still cook through conduction because it's touching the hot metal pan, but it won't actually be cooked by radiation. However, with a glass pan, what ends up happening is it still cooks by conduction because whatever you're baking is still touching the bottom of the pan. However, heat radiation can go through the bottom, and this is actually why when you are baking with glass cookware, you do need to cook at a lower temperature because it's cooking with radiation and conduction on the bottom of the pan. That's why if you leave this bottle of 7-Up outside, it won't heat up as much as this bottle of Coke. The clear liquid inside the 7-Up bottle would allow the light to actually pass through without holding much heat. Whereas the dark liquid inside the Coke bottle will hold the heat and absorb it and make it extremely hot. Well, that's heat radiation. Hope you learned a thing or two. See you next science lesson.